can or not? I run out of space, then God bless me. Okay, so this one is Jones' question. This is topic 10, question 2. Okay, so PR is the diameter. PR is the diameter. PR is the diameter. That means this will be 90 degrees. Okay, that means PQR will be 90 degrees. Okay, so that means PQS, this one will also be 90 degrees. Okay, so I'm looking at PQR and STR. Okay, then after that, that means PTS should also be 90 degrees, right? Okay, that means this will also be 90 degrees. Okay, because angles in a cyclic chord. So this and this add up to 90 ma. Okay, ma, John? So this will add up to 90. So this is also 90 degrees. Okay, then after that, PRQ is equals to SRT. So this is a common angle between two of them. Right, so if you look at PQR, right, versus STR, right? So you can see that they are similar. Two pairs of corresponding angles equal. This one, two pairs of corresponding angles that are equal. So far, okay? John, okay? Okay, cannot hear anything. Okay. Can. What about part 2? Okay, so part 2 is TSQ. Part 2 is TSQ. I think part 2 should be okay. So part 2, TSQ and SRQ. TSQ is this one. TSQ is this one. And XRQ. XRQ is this one. Oh, okay lah. I mean, because they are, okay. You know what to do. You know what to do. Okay. Okay. QPR and plus PRQ is 90 degrees. QPR plus TRQ. So this one, let's say I call this, for example, X. Then this angle will become 90 minus X. Okay, then this angle would be, this angle will become what? 90 plus X. This angle will become 90 plus X. Okay. TSQ. TSQ is supposed to be XRQ. Okay, XRQ. Then this will also be 90 minus X. Then this will be 90 minus X. Because these two, they add up to 180 lah. It's a cyclic chord. Okay, so you see if this is 90 minus X, right? Adjacent angles on a straight line, this is 90 plus X. Then this 90 plus X, this and this, right, will become 90 minus X. Because they must add up to 180. Okay? Then this one is because, I mean, you can look at alternate segment theorem lah. This is 90 minus X, therefore this is 90 minus X. Okay? So therefore you can see that these two are equal. Okay, TSQ and QRX are equal. Joan, okay?
Are we allowed to like prove that TS and XR are parallel and then just use alternate angles?
Can.
Okay, thank you.
If you see the solution, they also use this as method 2. Okay?
Okay, can.
Feel free to come in, go out anytime. Okay, don't need to, if you got question, just come in and you just shoot to me, okay? Okay, next I will go through F-year's question. Okay, so F-year is this one. Okay, F-year question. This one. Okay, this one. Okay. F-year, this is question number 1, right? Okay, F-year part 1 or part 2? Part 2, right? Okay, so where's F-year? Gone already.
She's not in the Zoom.
Yeah, I thought I saw her coming just now. Alamak. Okay, so I go through your one first. Okay. So
wait, I also have the same questions as her for this one. Like one
This one okay. So I go through. So this one, okay, basically the answer is A. So if you imagine, right, you are at A. Loser, I never charge my iPad. Let's hope it lasts. Okay. So here, right, okay, at A, right, basically, if you turn your head upwards, you see a triangle here, right? The gray color that you draw. This triangle, right, this angle because he is standing here, right? He's either standing here or here lah. So at A, right, if he lifts up his head, right, this angle cannot be cannot be more than 30 degree. It cannot be more than 30 degree. Okay, so basically this angle over here, right, if you see this angle over here, I draw it out at the side. Okay, Erin also got
This is a three-dimensional thing, right?
correct. It's a three-dimensional thing. Can you see the blue triangle being lifted
Yeah.
out? Then this is 6.4 meter. Okay, this is 3.5, right? So you need to check this angle. You need to check this angle. This angle must be less than 30 degree. Okay, it must be less than 30 degree. Okay,
Okay.
so I checked the answer. The answer is actually 28.7 lah. The answer turns out to be 28.7. Okay,
Okay.
you know how to find out. Okay, then after that, the second triangle is here. It's the one in red color. Okay, if I turn, let's say this is I'm facing front, right? Then I turn my head to the side. So imagine I turn my head. So this guy is facing front, then he turned his head to the right. This angle
Yeah.
must be more than 40. This angle cannot be more than 40.
Oh.
So of course, what you're interested in is you need to find the dimension. Okay, so you have 6.4 already lah. Okay, so maybe we can consider finding maybe let's see. Oh, you found this angle, very good. You found this angle, right? Okay.
Yeah.
Then you take this angle, right? Then you know what you can do? You can actually find this angle, this side. You can actually find this side. If you see what I'm pointing at, you can find this side.
Find AC.
Find AC, correct. Actually, this is C lah. So I will call this maybe something else, maybe Y or what lah. AY, let's call this Y lah, huh? Because C is
Yeah.
already. So you find AY, right? AY would be this. So this AY will also be this AY. Now if
Yeah.
you this triangle, right? In red, AY is here, right?
Yeah.
AY, and then there's another A. Okay, let me call this maybe Q. Okay, then you need to find angle QAY.
Yeah.
QAY must be less than 40 degree.
Okay. Okay.
You know to find out? So
Yeah.
as long as you check both sides, you find that A satisfies the answer. Okay?
Okay.
Okay. Okay, so next question. What's your next question? Is
Can
the
you do 3B?
3B is
Topic 9.
9. Wow. This one looks so scary. It looks like chemistry. Very lousy. Okay, so this one, okay. This is topic 9, question 3B. Okay, question 3B. Okay. Found a model of the molecule can be fitted into a cube of length. Then O is the center of the cube, which is equidistant to all eight vertices. Find angle shortest distance from E to AC. From E to AC, would be probably this line over here. So I have E A C. Okay, then you need to find this line, which is the perpendicular line.
Yeah.
Okay. So you found, let me see. Okay, you found everything. You have found what's the square root 200, right? So each side will be square root 200. This is square root 200. This is square root 200. This is square root 200. Okay. So then all of them will be equal. Oh, all of them will be equal. You know what? That tells me this angle here is 60 degree. Yeah.
Yeah.
It's all 60. Yeah. So with that, right, you can use that.
Why is it all 60?
Can you see all are equal? It's an equilateral triangle.
Oh.
Beautiful, right? 60 triangle. Okay.
Okay.
So therefore, you can use sine 60 equals to opposite over hypotenuse. Then done already.
So equidistant means that all three of the lines are the same length.
Equidistant. Okay, so this equidistant is because, okay, you see, you calculate, all of them are the diagonal of a square.
Yeah.
So all of them are of square root 200 because 10 square plus 10 square.
Oh, okay.
That's how I find out. You know?
Yeah.
Okay, let me see. Do you have any other question?
Not in topic 9 anymore.
Okay. Yeah. You never send me, are you sending? I never see. All from Javin not in yet. Maddie, got any question? Maddie.
Wait, can I ask for the notes? Like hold up. For the notes, hey,
Actually, any question you just text, okay, just text in the group. Okay, then so far only. Okay, Maddie, you were saying in the notes.
on topic 12, page 10.
Topic 12, page 10.
Yeah.
Opening my other computer. So I'm going to go to the notes. So you're talking about topic 12. Topic 12, page 10. Topic 12, page 10. Okay. Topic 12, page 10. Okay, what about the notes?
Like, do we have to memorize the whole table, or like is there any like specific important ones that we need to know and the rest are like derived from it?
What do you mean? Topic 12. Need to memorize table, man. Is there, do you mean the area of shaded segment? Circular measure, right? You're referring to topic 12.
Wait, no, topic 13, my bad.
Topic 13, Oh, okay. Topic 13, page 10. Yeah, I just opened my document. I'm looking at it. No need to remember. Yeah, or
It's like the important things to know.
you can derive one. No need to purposely go and remember.
But like derived from like which one is like the key one that can be derived from it?
Okay, so for example, remember in class, right, I said that if you treat, let's say for example, if you treat theta as an acute angle, as a basic angle, as an acute angle, how to memorize, right? If you treat theta as an acute angle, okay, so then what is 180 minus theta? What quadrant will it be in? This is quadrant 1, right? Then 180 minus theta will be in quadrant
2.
Then 180 plus theta will be in quadrant 3. 360 minus theta will be in quadrant
4.
Negative theta will be in quadrant
4.
4. So for all these, right, quadrant 2, basically only sign is positive. So sine of 180 minus theta is the same as sine of theta. Then the rest, right, cosine, right, will be negative. Cosine of 180 minus theta, because you treat it like negative cosine alpha, okay, also negative cosine theta. Okay, then tangent will be negative. So you see, I never memorize anything, but it just comes out very naturally because I see it as an angle in the second quadrant.
Okay.
Then for this one, you remember I did this in class also. So this one also tangent will be positive. The rest will be negative. Tangent will be positive. This one, cosine will be positive. The rest are all negative. Cosine will be positive. This one also, cosine will be positive. The rest are all negative. Okay, but with each quadrant, you got 3 formulas. You see, 3, right? So 3 times 4, 16. Then not forgetting the complementary angle formula, right?
Yeah.
Sine 90 minus theta equal to, okay, can okay.
Yeah, can, thank you.
Now, so these are all the total, how many? 1, 2, 3, 4, 5, 6, 20 formulas. No. What's 5 times 3? 15 formulas. Okay? Okay, so now I look at Ashley question. Ashley asked for...
Wait, is it done? For
Okay.
topic 9, right, there's still like question 5, II. Because like I found one of the bearings, but like the answer key, right? So it was like another way of finding like the bearings, and I don't know how to do the other one.
Question 5 II,
Yeah.
Question 5 II. They use sine rule. Okay, so there are total 2 answers, right? There are 2 answers, right? Because
Yeah.
it's basically sine can be first or second quadrant. That's why you have 2 answers.
Wait, no, it's for topic 9, 5, AII.
Correct. Okay, so you got 2 answers, right? One is you got 081.8, am I right? Then the other answer is 098.2. You know why? Because it's sine. You're using sine rule. So if you have I think if you use sine rule, you will get something like sine BCA is 0.98974 So you can see, since sine is like, because sine BCA is positive, right? Remember, then that means BCA is in quadrant 1 or quadrant 2. It can be in quadrant 1 or quadrant 2. So you need to check. If it's quadrant 1 or quadrant 2, right? This is positive, right? It can be so-called alpha, or it can be 180 minus alpha. That's why you have two answers.
Oh, so like basically it could be in like two quadrants, so you have to find both of them.
Correct. So must be careful, because it's also in a part of a triangle. You must make sure that it makes sense.
Oh, okay.
可以啊? Okay.
Yeah.
Okay. Then next, I will look at your next question, which is topic 12, 3C. And topic 12, 3C. Okay, topic 12, 3C. Topic 12, 3C. Okay, so this is topic 12, 3C of revision package. Okay? Okay, so I'm supposed to find the area of the shaded region. Okay, I think this one, okay, I can find the dimension of PCB, right? Okay, so if I have OCA, it's 0.87. PCA and AOB are straight line. PB is a tangent to the circle at B. So if this is 0.87, right? This one also be 0.87. Then
Yeah.
this should be 0.87 times 2? 1.74. This is 1.74 radian, huh?
Is it
Then,
because of the circumference
correct.
or equals to the other one?
This plus this equals to this exterior angle of triangle.
The exterior of triangle is like 180 minus like the two angles there.
Correct. So like these two, right? I mean, okay, they add up to pi, right? So this and this, they three add up to pi, right? So this angle will be like pi minus 1.74, since they must all add up to pi. Therefore, this will be 1.74.
Okay, yeah.
So you either do it 2 steps, or you can straight away say that this plus this equals to this one.
Okay.
Okay. So from here, right? Okay, you can find the area of this segment. Okay, segments BC. Segment BC.
Okay.
Yeah. Then you take the area of this triangle minus the area of this segment.
How do you find the area of the triangle?
Let me see. Let me just go to the. So from earlier on, you found OA. OA is 3.877. Is there a lot of, how do I find this? That is a good question. Oh, okay, I know. Wait, I don't know. Yeah, thinking. Okay, I know that this one is 10. This triangle, this is 10. This is 10. This is 90.
Yeah.
How to find these two sides? Okay, how do I find OCA? Oh, okay, so I can take this angle.
Yeah.
I can find this side. I can find this side. Okay, I know how to do it. So I look at this triangle, PAB, right?
Yeah.
Okay. This one is 0.87. Then this is actually 10 cm.
Yeah.
Then this one, right, use Picasso to find PB. Okay,
Yeah.
PB. Then you can find PA, right?
Yeah, I said I know how to do already. Because at first I didn't know like where did the 1.74 radius for the COB quadrant come from.
Okay. So can do, huh?
Can, yeah.
Very good. Okay, very good. Okay, all the best to you for this question. Okay, so next one, I'll be looking at the next question now. Okay, the next question is topic 13, question 2. Topic 13, question 2. Let me just go to my this one. Okay. This question I think got somebody asked me in class. Very hard, this one very hard.
Yeah.
I also struggle. Okay.
Wait, Mr. Tan,
Yes.
is today just revision practice? Revision package.
Yes. I'm just going through questions from the revision package. Every consult will be like that.
Oh, wait,
yeah.
when will we be going through time pack?
I mean, up to you all. You all can send me questions. I actually there's no fixed sequence. Yeah. So you send me any question, I'll go through any question.
Okay.
Can I just point to note? I hope I can last long. I don't know, my iPad dying. Okay. Sorry, I forgot to charge. Okay. So sine x minus 130. Okay. Can I say this is the same as negative of sine 130 minus x? See, okay, Ashley?
Wait, I really don't get this part.
Oh, okay, because sine theta is the same as negative of sine theta. Negative sine theta is the same as sine of negative theta. So if you treat this as theta, right, then this part is like negative theta. Okay? This part is
Oh,
like
okay.
Make sense? Huh?
Yeah.
Yeah. In case my in case my iPad down. Prepare paper just in case. Okay. My iPad. Okay, so this, right? Okay. Therefore, can I say that this is the same as negative sine of 90 minus x minus 40 degree? Can I say that? So I'm
Yeah.
thinking x minus 40. I'm really thinking of x minus 40. Okay.
Yeah.
So you know how complementary angle formula works, right? So this was actually the same as negative cosine of x minus 40.
Yeah.
Which is, so that's the numerator. Okay.
Yeah.
Now for the denominator, right? Can I say that this is also the same as cosine x minus 40 degree? Since we know that cosine negative theta is the same as cosine theta.
Yeah.
Give me 1 second. Let me use my other lab. This one should charge very fast. Okay. So therefore, I have 1 unit of cos x minus 40, 2 units of cos x minus 40. Right now. So I actually I have cosine x minus 40 negative at the top. Below I have 2 cosine x minus 40 degree. Cancel. My answer turns out to be negative half. Okay?
Yeah.
Yeah.
Wait, Mr. Dan, for the negative sign equals to sign negative, that one we have to memorize, right?
Yes, you have to memorize. So this
I
one,
thought it depends on the quadrant.
it doesn't matter what a theta is. Theta can be in any quadrant. The formula always works. It's just that in order to help you to remember, right, I just imagine, okay, imagine if my theta is acute lah. Imagine theta is first quadrant. Then negative theta will be fourth quadrant. Okay, negative theta will be fourth quadrant.
Yeah.
But it doesn't matter. It works for all quadrants. It works for all quadrants.
Okay.
Okay, it works for all quadrants. Okay, so for example, if I imagine theta as a cube, the imagination is just for me to remember. Then I know that actually negative theta will be in what quadrant? If theta is in quadrant 1, negative theta will be in what quadrant?
Quadrant 4.
Quadrant 4, right? So I know quadrant 4 only cosine is negative, positive. So cosine negative theta is the same as cosine theta, whereas tangent negative theta is the same as negative of tangent theta. Since quadrant 4 is the C quadrant, sine of negative theta will be negative of sine theta. Is that okay?
And even if like the quadrants are in like Q2 or Q3, it will still be the same.
Yes. Okay, so let me give you an example. Let's say if I take theta as if out of my imagination, if I take theta as 100, Is cosine negative 100 degree the same as cosine 100 degree? Answer is yes, they will still be the same. Okay?
Yeah.
The imagination is just for you to remember. That's all. Okay?
Okay.
Actually, it works all for all angles. Is tangent of, let's say, quadrant 3 is
But
negative.
Mr. Tan,
Sorry?
for cosine negative 100, isn't that in the third quadrant for cosine negative 100?
Correct. But it still works. It still works. The formula actually works for all quadrant. It works for all quadrant. It works for.
But if it's in the third quadrant, how can it be positive?
Okay, it's a good question. Okay, so the idea is that, okay, if it's a third quadrant, right, this is a negative, and then it turns out that this is also negative. Because cosine 100 itself is negative. So you're right to say that it's not positive, but this is negative and this is also negative. That's why they are still equal. That's why they are still equal. You see, if it's third quadrant, right? What quadrant will this be? This will also be third quadrant. Already this is second quadrant. This is third quadrant. They are still both negative. Okay, so it works for all. You can key into the calculator. You see that they are the same, right? It's just that to remember them easily, right? You can imagine if theta, just treat theta as somebody in the first quadrant, right? Okay, I happen to pass by the first quadrant. You can remember that everybody else in terms of the quadrants lah. Then you know that cosine theta is the one that's positive.
Okay.
Can. So yeah, this is to show you all that it works for all quadrants. Like second quadrant, it works. Third quadrant, it also works. Okay? Okay. Okay, so okay. Is there any other question? Okay. Maddie, Ashley, Mulan, any question? Or Janelle, any question? Or Janelle got question. Janelle has asked something just now. Let me find. Okay. So Janelle, this question is from where? Sorry. Where is this question from? Jervin sent, but she never put the question number, so I need to find. Okay, it looks like where? What question is this from?
It's the topic 9, question 5.
Which topic
A
9?
part 2.
Topic
5. Sorry, not topic 1, topic 9.
5. Okay. Topic 5.
Wait, but some of the questions that Effia and Jervin sent, I also like need those.
Okay. 5A part 2, okay. This one,
Yeah.
Okay. Don't worry, you just highlight later on, okay? Whatever I just help me remind me. No, my brain very forgetful. So this one ABC are on level ground. The bearing of B from A is 300. A part 2, part A part 2. Okay, so let's see, okay. Okay, so this one, okay, am I right to say you only got one answer?
Yes, then I don't understand how you get the other one.
Okay, it's because you use sine rule? You use sine rule, right? Okay, the reason is because, right, just now I happen to go through this question as well. So because sine, right, can be acute or obtuse, that's why you can have two answers. So it can be alpha or 180 minus alpha. That's why you can have two answers. Fair? How does that sound? Janelle, you are muted in case you are saying anything.
Oh, it's okay. I get it, yeah.
Yeah, okay, good. Okay. Any other, what's your next question?
Wait, there's like the topic 10, the question 2, then the part 2.
Topic 10, question 2, part 2. Topic 10, question 2. Topic 10, question 2, part 2. Topic 10, question 2, part. Okay, topic 10, question 2, part 2. If I'm not wrong, just now I also got go through. Let me see if I got it somewhere. Okay, sorry. Is it this one? No. Is it this one? Yes. Okay. This one, right? Okay, okay, you're muted. Okay, so because, okay, let's say I call this x, okay, let's say I call this x, then this is 90 degree from part 1. Then this will be 90 minus x, right? Okay, so if this is 90 minus x, right, by alternate segment theorem, this will also be 90 minus x. Okay, now if this is 90 minus x, this will be 90 plus x, adjacent angles on the straight line. Okay, now if this is 90 plus x, then angles in opposite segment, angles in a cyclic quad, this will also be 90 minus x. Okay,
Okay, thank you. Wait, Mr. Tan.
Yes.
This question is like not any like of the revision package one, but it's like the property for the two angle is the angle at circle is 2 times the angle at the circumference.
Correct, correct.
How do you like know like which angle at the circle, which angle at the center is like half of the which angle at the circumference?
So you must always look for an arc, right? This same arc, right? This arc, right? It gives you the endpoints of the arc, right? Basically points to an angle, right? It so-called surrounds an angle at the center, right? The same endpoints of the arc shoots you an angle to the circumference. That's how it looks like. Okay, there are many ways in which this triangle this can appear like. So it can appear like that. It can also appear like this, right? So if the same arc appear this way, right? I mean this same arc, right? It can look like that. Right. So it can be along the diameter as well. So if I shoot an angle to the center, the same arc can also shoot the endpoint of the arc, right? Can also shoot an angle to the circumference. So you notice that this is the common arc, right? The same endpoints of the arc shoots an angle to the center and then shoots an angle to the circumference. If I extend this circle even more, right? I can also, sorry, wrong, bad circle. Okay, so for example, this arc itself can also be very, very big, right? And the endpoint of the arc can still shoot an angle to the circumference. Sorry, to the center, Okay, let me go a bit wider, right? So it shoots an angle to the center. Then this will be the angle, right? Then the same endpoint of the arc shoots an angle to the circumference. Okay, then you can see this will be like double of this. Same arc, the same endpoints of the arc shoots an angle to center, angle to circumference. Is that okay?
Okay, I understand that, but then like there's like if there's some questions like question 3 from the topic 10 revision package that there's no like common arc, so I'm not sure how that would apply.
Okay, question 3, part 1, part 2, part 3, part 4.
No, it's I could understand the like answers, but like I mean, because there's like no like common end points in like I don't know how to say it. Sorry.
Okay, I mean, if let's say there's no line, then you might need to draw your own line. But other than that, if there's no need to use, let's say there's no opportunity to use that property, right? Then don't need to use other things. Use other things. You don't have to.
Because like the answer key did use the angle circle one, and yeah, that.
Okay, so you are looking at
Center.
topic 10, question 3, Okay, reflex angle SOU. Okay, I understand what you mean. So you notice, okay, here, right, the person draw her own line. She draw her own line. Can one. Okay, so there are strategies. One strategy is you label everything you can. Another strategy is you draw your own line, draw extra line to the graph. Can, yeah, so to answer your question, yes, it's possible to draw your own line. You can do that one. Okay?
Yeah, okay, I understand it now. Thank you.
Okay. Any more question?
Wait, Mr. Tan, this
Yes.
is not your revision package, but like for the alternate segment theorem, right?
Yes.
How do you tell which is the angle that corresponds with like the x that you labeled?
Okay, so let's say you draw the alternate 7 theorem always got tangent one. Okay, so
Yeah.
then there is what we call the you can also remember it as the tangent chord theorem lah. So tangent chord theorem is actually better because you will remember that there's a tangent,
Yeah.
and there's a chord, right?
Okay.
So the angle between the tangent and the chord, right, is the
Yep.
same as the angle between the chord and the circumference. Is the same as the angle opposite the chord, right? So this chord, right, you see opposite the chord.
Yeah. Yeah.
These two are equal. Okay, so the angle between the tangent and the chord is the same as the angle opposite the chord. Opposite means
Oh, okay.
opposite
Okay.
can hopefully that
Yeah.
sounds better to remember. Okay. Any other question?
Will there be a Zoom meeting tomorrow?
Tomorrow, yes. So you all can refer to the schedule that I posted on the WhatsApp chat group. Okay, so it is over here. It's over here. Wait, okay, so it's in both classes now. Okay, let you see. Yeah, wow, so many people sign up, but so few turn up. Okay, yeah. So you can see Tuesday, Wednesday, Friday for this week. 2357, sorry, 2357. Okay. So
Okay.
I mean, I understand not everyone can. You don't have. It's not for you to come every day. It's for you to choose a day to come so that sometimes you cannot come on all the days. I mean, some days you cannot come, then you can choose another day to come. But basically, it's just for you to ask questions. Yeah, it's like giving consultation like that for your revision package, which we unfortunately sometimes don't have time to do in class lah. Then if I do in class, sometimes if I explain for one person, everybody else would be bored ma. So yeah, with more sessions, hopefully it keeps the class size small and easier to help. Okay.
Wait, Mr. Tan, there's like question 2B, right, of topic 9. It's like one of the photos that Jervin sent. I need help with it.
Question 2B of topic 9. So it's this one. This one is not hard. This one is not so bad. It's not so bad. This one? Correct, okay, so okay, so this one is topic 9, question 2B. So you see the vertical tree, right, is growing at A. So imagine at A, there's a tree that is 10, that is, sorry, I don't know what is it. I call it height of the tree. Okay, then you draw like that, right? You draw like this, right? Okay, so that is a 90-degree vertical tree. This angle of elevation, right, is 10 degrees. Okay, then so if you look at this triangle here, right, then this is height, this is 112, this is 10 degrees. Yeah, just use Picasso can find already. Okay, so you can use for example, tangent 10 degrees. This is equals to opposite over adjacent. So your height is basically 112 multiplied by tangent 10 degrees. Okay?
Okay, I understand that, but then like what's the tree like the same direction as the BA? Because like I thought vertical means like
Yeah, okay, so
vertical.
it's like I'm drawing is 3D. It's 3D. It's like I'm drawing 3D. Okay, so for example, if you look at, let me see, okay. If you look at, like you can see, can you see my laptop? Right? The tree is pointing out this way, man. The tree is pointing out this way. Literally pointing out 3 dimensions. It's like that. Pointing out this way. It's out of the laptop.
Okay.
Yeah, so it's like you look at the tree, right, and it's pointing outwards like that. But when I draw, I can't draw 3D lah. Yeah, I tell you my art always fails, so I can only draw like as though it's pointing outwards lah. Correct? So when I draw it, this is actually 3D. It's actually 3D. It's pointing outwards. It's pointing outwards. Can all?
Yeah.
It is
Wait,
not.
then
It's not flat. It's not 2D. It's 3D.
wait, there's also like the 4B that I don't know. For
Okay.
4B, like from
4B.
topic 9.
Oh, 4B very fun one. Okay, 4B, it is this one. Okay, so okay, the hero to this question is basically area of triangle. Area of triangle. Okay, so let's, for example, you call this R, okay? Then this will also be R, this will also be R. Can? Okay, so the thing is they have the same area, right? They have the same area, okay? So let's call this angle here now. Okay, so the thing is an area of triangle AXY, area of triangle AXY is perhaps supposed to be half times AB times sine of angle AXY. Is it okay?
Yeah.
AYX, sorry, AYX. I was讲什么? AYX, AYX. Area of triangle AYZ should be okay. So half times R square times sine of angle AYZ. Is that okay?
Mm.
Now, you know that they are equal. You know that they are equal, right? That means it tells you that these two guys are equal. They are equal. Am I right? Is that okay,
Yeah,
Janelle?
yeah, sorry.
So, if I cancel half, I cancel R square. Is it telling me that AYX and AYZ are equal?
Mm.
But they are not congruent. Because they are not congruent, right? Not congruent means what? The corresponding angles it's not equal. They are not congruent. So this implies that AYX, right, is not equal to angle AYZ. Okay, so for the sine to be equal, right, it must mean that angle AYX could be equal to 180 degree minus AYZ, right? Because we are talking about sine. Sine, if they are equal, right, the angles either are equal or they are supplementary to each other, since it's first and second quadrant.
Mm.
So can you see that from here? What does it tell you? AYZ and AYX, right? They are on the straight line.
Oh,
Okay.
because like 180.
They have the 180, so therefore they are collinear. They add up.
Oh, okay. Wait, yeah, that makes sense. Thank you.
That's the idea. Actually, Janelle, any question?
Wait, Mr. Dan, for like the tangent from exterior point, right? What does that mean?
Tangent from exterior points like that. It's better to know it as equal tangents. Okay, so instead of tangent from exterior points, if you can, you write it as equal tangent. So it looks like this one. It basically, actually you take physics or chem?
Physics.
Physics, it looks like the torchlight,
Yeah.
it looks like a torchlight source shining onto planet, moon, I think, or not planet. So moon is a star, right? Okay, so like that, these two are equal tangents. We call it equal tangents, or some people say tangent from external point. Okay, it's better to call them equal tangent.
Wait, another property of the equal tangents is that there's like a 90 degree somewhere, right?
The 90 degree is if you have this part, let's say they point towards the center, right? Right,
Yeah.
then these two are 90 degree. That
Okay.
property is called radius perpendicular to tangent. Radius perpendicular.
Oh, okay.
That will be like another one, which is like very easily deducible from this property as well.
So as long as like a tangent, like a radius, then you can use that property.
Correct. Sorry.
Okay.
Tangent. You mean the use together, And you can use together. But if you want to use this angle to be 90, the best is to write the reason again. Write a second reason.
Yeah.
You know?
Okay.
Wait, Mr. Dan, you can just like write like tangent properties for like this kind of like
Yes, you can.
Yeah. So it's okay.
Yes, you can.
Wait, Mr. Tan, for 5 part B, right? Like topic 9.
Topic 9.
Like since like I've figured out that the tree like from in section 2 is like actually like the same direction as the
Which topic are you
okay,
referring?
topic 9, wait.
Helicopter one.
Cause yeah, it looks similar to the tree one, but is it like
Janelle, this question, actually is from JH2.
yeah, I know. It's like I don't know.
Okay. This one got is a okay. JH2 Picasso, right? There's this kind of equation. It asks you to form simultaneous. Yeah.
Yeah.
So if you remember, it's like your JH2 quiz 2 or quiz 3 like that. Then like it's in AFL, then your teacher keep making you do the same question over and over again. Yeah. Yeah. So this one, right? Okay. X is the midpoint, right? You call this, for example, Y, and you call this Y, right? Okay, so the first one, if you look at this
Oh wait,
triangle,
I think I know already.
you know already,
Yeah, I think I can try again later.
again, use the red and
Later I
the
can.
triangle. Then do
Yeah, I
simultaneous.
think it should be okay.
Okay,
Yeah, it should be okay.
You're the first customer of the consultation series. Okay. You'll get a VIP card.
Wait, Mr. Tan, if like you don't have enough time to like do all the papers, right? Is doing time practice or revision package like better?
Both must do. You try to do at least 1 or 2 time practices, but revision package you must do. Because revision package you do, right, you feel secure. You have like done through every what CC are you from?
Sorry?
CC are you from?
Squash.
So for example, right, okay, squash is like you playing friendly match. Time practice
Yeah.
is like you playing friendly match. Okay. Revision package is like you going for different trainings. One training you practice smash, one training you practice defense, one training you practice footwork, one training you practice fitness. Yeah,
Okay.
you get the idea, right? So both are
Yeah.
important. You cannot play the match without your proper foundation.
Do we
Can
have to do the time practices under like a practice setting? Like the actual time setting?
if you can,
Okay.
if you can. So of course it will give you an idea of what all the time practices basically from time practice 1 to time practice 4 is the past few years backwards. The quiz 3 of the earlier years back. So time prac 1 is 2022 quiz 3. Prac 2 is
Oh,
2021 quiz 3. In time prac 4 is like 2020 or 2019 quiz 3. So the time prac 1 is the most recent one.
okay.
Now, in case you cannot find a solution, you can check the WhatsApp group. I have posted in the class chat group.
Okay.
My advice is do the revision package first, then after that do 1 or 2 time prep to have a full friendly game. Friendly game.
Okay.
Mm.
Which is quiz 3 gonna be hard?
Quiz 3 going to be hard. I think same as the previous law, same as the other 2 law, all same. Don't worry lah.
Okay.
I tell you hard also no use, I tell you easy also no use. So doesn't matter.
Okay.
You will still do your best, right? Whether your
Okay.
opponent strong or not strong, you will still do your best. Right?
Yeah.
Even whether the SYF judge strict or not strict, right? You will still do your best. Okay. That's the most important. Yeah. The best is good enough really. Yeah. Any more question?
I think that's all.
Hmm.
I don't have any right now.
Yeah, that's all for me too.
Okay.
Okay, lor. Okay, so I'll stop here today. So if you're free tomorrow, tune in same time.
Yes, okay.
Okay, see you.
Okay.
Thank you, Mr. Tan.
Thank you, Mr. Tan.
Yeah.